Welcome everybody. In this channel we are focusing on developing the mathematical mind, and if you are interested in doing that, please consider subscribing. So we have a question: prove that the number a is equal to 7 positive 7 squared positive 7 cubed plus extra plus 7 raised to the power of 2000 is divisible by 2801. So this is the question that has been given, and the solution. Let's get the solution started. Now, the first and foremost observation that you should have here is, we observe that 1 positive 7 squared positive 7 to the power of 3 positive 7 to the power of 4 is 2801. You can try that out and you will be in a position to know that this is true indeed. So having got that, what I would do is I would be rewriting the given number. Given that a is equal to 7 positive 7 squared positive 7 to the power of 3 plus etc plus 7 raised to the power of 2000 can be rewritten. Now what is the idea? The idea is to rewrite this entire series, quantities that we see here, as quantities involving this product 2801. If we can do that, then clearly we can conclude that a is divisible by 2801. So that is our objective. So having got that objective, what I wish to do is I would like to take 7 out. If I were to take 7 out, I would get 1 here, I would get 7 here, I would get 7 squared here, I would get 7 to the power of 3, and then I would get 7 to the power of 4. So I close that off positive. Now 7 with 7 to the power of 4 gives me 7 power 5. So I need to start with the next 7. In that case it is going to be 7 raised to the power of 6. And inside we would have to have 1 over there, because this ends at 7 power 5. Now this has to start with 7 power 6. So that's why I have taken 7 power 6 out, and I can rewrite this as 1 positive 7 positive 7 squared positive 7 to the power of 3 positive 7 to the power of 4. Now 7 power 6 with 7 power 4 gives me 7 power 10. So the next quantity should be 7 power 11, right? Because this ends at 7 power 10, this ended at 7 power 5, so this started with 7 power 6, and this is ending at 7 power 10, so this has to start with 7 power 11. So it's going to be 1 positive 7 squared positive 7 power 3 positive 7 power 4. This ends at 7 power 15, so this has to be starting at 7 power 16. So it's going to be 1 positive 7 squared positive 7 power 3 positive 7 power 4 plus etc. I hope you are able to get the gist of it. Now if I were to proceed like this plus etc., the last term should include a quantity over here, so that quantity multiplied this quantity gives me 7 raised to the power of 2000, right? So definitely the quantity that I would be placing inside should follow this pattern: 1 positive 7 squared positive 7 to the power of 3 positive 7 to the power of 4. So this quantity multiplied with this quantity should give me 7 power 2000. So clearly, without any doubt, that number should be 7 raised to the power of 1996, because 7 raised to the power of 1996 added with 4 gives me 7 raised to the power of 2000, and the subsequent terms would be 7 cubed with 7 raised to the power of 1996 followed by 7 squared, 7 and 1. So that would complete the terms, because the term before 7 raised to the power of 2000 is going to be one shot, right? So this is going to be 7 raised to the power of 1996 plus 3. That's going to be 7 raised to the power of 1999, right? So clearly this is the pattern that we are looking for. Now we know that 1 positive 7 squared positive 7 power 3 positive 7 power 4 is nothing but 2801. So I can place that. So this is equal to, now clearly before I could do that, I can see that 1 positive 7 squared positive 7 power 3 positive 7 power 4 is a common quantity. So I can take that out and rewrite the terms in this fashion. 1 positive 7 squared positive 7 power 3 positive 7 power 4. This is the common quantity. So if I were to take it out, so I would get 7 positive 7 power 6 positive 7 power 11 positive 7 power 16, etc., etc. The last term will be 7 raised to the power of 1996. Okay, now I can state it. Since 1 positive 7 squared positive 7 to the power of 3 positive 7 power 4 is equal to 2801. If I were to take this as 2, therefore 2 can be rewritten as, this is equal to 2801 times 7 positive 7 power 6 positive 7 power 11 positive 7 power 16 plus etc. plus 7 raised to the power of 1996. Now clearly this implies A is divisible by 2801 because we got 2801 to be the factor, and we started with A, right? These are the deductions that we performed. Finally we have come to this point, and then this is the conclusion that this implies A is divisible by 2801. So that is the end of this beautiful question, students. I think this was this was presented in a international mathematical journal originating from Italy sometime in the year 2000. So that's some historical facts about this problem.